So today's webinar will be on data analytics with Nime. So yesterday, Mr. Shen already touched a bit on data analytics. I'll expand a bit further with the software that we're going to use on our program. And so the structure of the webinar as follows. So first, I'll start a bit on introduction about data analytics. Then I'll move on to the Nime introduction. It's a software for data analytics. And I'll do some demo on that. And after that, I'll do some introduction on the machine learning concepts. All right, so let's start with data analytics first. So the data in the data analytics, what does that mean? It's basically like the data is the quantities of characters, symbols on which operations are performed by a computer. So it can be stored or transmitted in the form of electrical signals recorded on any form of storage device. All right, so that's data. And if that's data, well, what is big data? Big data is basically the same as data, but the size is bigger than that. So it's a collection of data that is huge in volume and growing exponentially with time. The data is so large and complexity is big that none of the traditional data management tools can store it or process it efficiently. So we'll use like so specialized tools for that to manage those kind of big data. All right. And yesterday, Mr. Shen already touched a bit on this, the 5 V's of big data. They are velocity, the speed which data is emanating and changes during the diverse data sets. Second is volume. Volume is basically the sheer volume of data being generated every second, like how big, how many data points there are in the big data. And variety, like how many different kinds of data there are being produced. And veracity, like whether it's reliable, like no corrupt data or anything. So that's veracity. And value is what each of the data points value being generated. Okay, whether it's useful or not. Okay, that's value. So next, let's move to the next one. And this is also from yesterday's webinar. Like these are the building blocks of technology, like different maturity levels. For L1 is for data generation, and then L2 is for visualization. Then L3 is for data storage, like how we manage the storing of the data, and data formulation, how we utilize the data stored and how we formulate based on that. And L5 is basically data analytics, like we use the data stored and do some analytics on it. And what is data analytics? Okay, so it's basically refers to the technique, not the data. Okay, so the technique that we use to analyze the data to enhance productivity and business gain. Okay, so it actually focuses on the technique rather than the data itself. Okay, so these are the evolution of maintenance strategies in the manufacturing industry. So previously, they only do reactive strategy. Basically means like only when there's something needs to be fixing, they do the fixing. So like when something breaks, they do the fixing. So that's reactive. And next stage is like preventive, like they do scheduled maintenance to prevent breakdowns so that it's maintained properly and it doesn't cause for it to like break down or anything. So it's basically rely on regular maintenance. So that's preventive, and predictive is data driven failure prediction. Like based on the data that we're collecting from the sensors, it can actually predict when it's going to happen. So that's next stage of predictive maintenance. Okay, and prescriptive is like if something going to happen, what are your action plan? That's prescriptive. So these are the different strategies used in the manufacturing. Okay, and these are the data types. Sorry, they're not data types of data analytics. Okay, so the first is descriptive. So what's happening in my business? Like so the data it describes the data, and diagnostic is what is it happening actually, like the drill down and we find the root cause and ability to isolate all confounding information. And predictive is like what's likely to happen, so we predict what's going to happen based on the data. So and the fourth one is prescriptive. What do I need to do? So these are the 4 types of data analytics out there. So and these are the examples of use cases for the data analytics. So the first one is text analytics. For example, the sentiment analysis for customers. Like let's say you gather some feedback on some review, and then based on the words they use to describe, to give the feedback, you can actually determine the sentiment of that feedback, like whether they are frustrated or they're happy with the service or not. So we can actually, without even reading, we can actually group it into like whether it's a positive feedback or negative feedback. So that's one of the usage of text analytics. And HR analytics, like in the HR department, like usually for HR admins, so they use the data of their employees to predict whether like how long they're gonna stay in that employment, so that they avoid they'll get ready instead of like just waiting for them to like give the resignation letter. So that's in the HR analytics department. Okay, then crime prevention. It's like you gather data on the crime that's happening around, and you focus all your efforts in the particular target area to effectively prevent the crime in that particular area. So that's the use of data analytics and crime prevention. And in the customer lifetime value, it's like the loyalty programs. Like we can track the customers' data, like where are they spending money on which products, so we can actually track their value, lifetime value, using data analytics. Okay, so like whether the promotion campaigns they conduct is successful or not, so we can actually see like what's the outcome of any marketing campaigns. So that's the use of customer lifetime value prediction. Okay, analytics. And in healthcare analytics, it's like we collect data, like let's say smart watch or anything, so it can track our heartbeat rate, heart rate, and other information on our health, and then actually we can use it to monitor our health conditions and all. All right, so that's the use of data analytics in healthcare. Okay, so there are plenty other uses for data analytics. So these are the ones that I picked as an example for you to see. All right, and next move to the next slide. So there's always a confusion between analysis and analytics. They are different things, but sometimes people use it interchangeably. So to give you a better understanding of what's analysis and what's analytics, analysis we're referring to the data, like what we infer from the data. Okay, so that's analysis, like typically large sets of data. So we use mathematical principles like statistics and computer software to analyze the data. So we are more focused on data. So that's analysis. And when it comes to analytics, so we focus more on the techniques. Okay, so this is a science of using data to build models that lead to better decisions. So we focus on the techniques to make better decisions and to add value to individuals, companies, or institutions. So that's analytics. So analysis is we focus on the data, like what it is, and analytics we focus on the technique. So that's analytics. Okay. Any questions up till this point? No. Okay. So I take it as no. So let's move to the next one. And there are confusions on on what is data science and also what's data analytics. So they are, even though they share some of the things in common, but they are different fields. So data science is like a larger set of data analytics. Like they look at how to formulate the question, like how to ask the right questions, while data analytics is about finding the answer to those questions. Okay, that's the difference between data science and data analytics. And data science, we work with the unidentified data, like we don't know the relationship between the data yet, and we try to find the relationship in the data. So that's data science. It usually it requires machine learning, and we make predictions through testing. Okay, and in data analytics, we use known data to do data analytics. Like we more or less know the relationship between each of the features, so that we can do some analytics on it. And it doesn't exactly need machine learning, but we can use machine learning. You get what I'm saying? It's like it's not a requirement, but we can still use machine learning. And also we can use it. We can do visualization as part of data analytics. Okay, that's the difference between data science and analytics. And usually data scientists are like those in the senior positions, and data analytics it's like an entry level position. So that's a difference between data science and data analytics. Okay. So let's move to the next part of our webinar. It's about KNIME software, and I'll do some demo after that. So what is KNIME? Okay, so KNIME is the software that we use to teach data analytics over here. The abbreviation is Constant Information Miner. So it's a German word, and it's a free and open source data analytics reporting and integration platform. So you can do data analytics, you can do reporting, you can do visualization, and so on. So more or less, the interface looks like this, and this is how a workflow looks like. If you have experience with Node-RED, it is something like that, where you drag and drop the nodes and you do some wiring, and it's easy to configure, pretty intuitive. So that's the interface of KNIME. So as I said earlier, it's like a drag and drop platform with various node options, with specified functions that build up into executable workflows. So if you look at the flow, it goes from one stage to another. Like the data that you acquire in the first stage, you do some modifications, you do some manipulation, and then you feed it into the later node to do some processing, all right, or training, something like that. Okay, that's usually the workflow for in KNIME software. And this is the KNIME workbench. So you have all these panels in the software. Like at the top left, you have Nime Explorer, where you can see your directory and everything, like where your files are, like how it's being organized there. And under that, that's Workflow Coach. So Workflow Coach is like it will suggest you what node to use, which node to use after each of the stage. Let's say you drag and drop a file reader, and it will suggest you what's the next node to use, and it'll give like a percentage what are the nodes that others are using after this specific node. It's really helpful when you do data analytics in that software. Like sometimes you'll be like clueless what to do after this, and based on suggestions, you can more or less like decide what to do after that. And the next under that is a node repository. It's where all the nodes are found. So it's based on your local repository. And if you want any other nodes that are not there, you can actually download it from online on their mirror link. So yeah, and so the middle the middle one is the workflow editor, where you do your editing and all, like you drag and drop and everything. It's like a canvas view. Drag and drop, do the wiring and everything in the workflow editor. And on your right, that's node descriptions. When you select each of the node, it can tell you like the description about it, like how to use it, like what's required and all. Something like what we did in Node-RED. For those of you who attended the other course. And the bottom is outline, like you can just do some navigation, easy navigation on based on the outline. And the console is like whether when you run the program, it will give you like whether it's run successfully or not. So that's basically about KNIME Workbench. And a single unit of in the KNIME is called node. Okay, so it's a node, and then workflow is like connected nodes. So connection or multiple nodes that are connected is called a workflow in KNIME. Okay, and the nodes, each of the nodes will have something at the bottom to show the state. So there are 3 states of each node, like whether if you configure properly, it will have like a yellow light in the middle. If it's not configured properly, it will have like a warning sign with a red dot. And after you execute, it will get like a green light on the right at the bottom. Okay, so these are the 3 states of the nodes. So you can see like whether it runs successfully, whether each of the node is run successfully or not. Okay, so this is an example KNIME flow. So first, usually what you do, like you do data acquisition. So you have data readily available, whether it's in CSV format or SQLite DB or like XLS. So all those kinds of data, you do some reader to drop to import it into KNIME. So that's data acquisition. After that, you do data cleaning and manipulating. Okay, and after that will be data visualization, or you do some model training based on that. After the cleaning part, and then the visualization. After the visualization and the training and all, you can do data reporting. So it can actually generate the report automatically using the platform. Okay, so before we move to the next part, let me show you how the KNIME platform works. Okay, let me pull up my next window. Right, as I showed you. Okay, this is the Nime Explorer. So it will have like a connection to KNIME Hub and the KNIME example server. And if you have like your own server running, so you have that, and your local workspace, so where you have all those files in your local directories. All right. So I have all these files. The one I'm going to use is this one, ttdemo, right? So what I did was like I stored all the data inside a folder called data. So, and I'm going to use it in this workflow, editor here. All right. So let's open up this churn prediction model, building the churn prediction model. Okay, this is the one. Should I expand a bit so that you can see it clearly? So the font size is okay, right? Okay. I take it as a yes, okay. So just let me know if you can't see or anything, all right? And okay. So this example is on churn prediction. So what is a churn prediction? Churn prediction is like you have like a subscriber list, and you can actually predict whether this particular subscriber to your service is going to churn or not. Churn meaning like whether they leave the service or not. So let's say in this case, it's a telco provider like something like Maxis or DG. So they have the data for their subscribers for the service, and all those data like their usage statistics are collected, and they can actually predict whether a particular subscriber will churn or not. So that's the use case. That's the example it's about. Okay, first we need to do the data reading. So over here, okay, the first thing is like about calls data. Okay, so if you want to see what's inside the data, so like this is the configuration page. Okay, so when you want to upload, you can actually use like a custom URL, or you can select a particular location in your local directory, or relative to your location, you can actually point to that particular data from there, so that it's like easier when you export to other computers. So it will be there when it's referring to that. Like, let's say you use like a local file system and you point to a location in your own user directory with your own name. When you share with other people, it will be very hard, very difficult. So usually what we do like relative pointing to the data. Okay, so these are the settings you can do, like over here. So because the first column is about the name of the column, so it ignores the first row. Okay, sorry, the first row is for the name of each of the columns, so we'll ignore that. So that's this box here for, and these are extra options to skip empty columns, like missing values or anything. It will just skip that particular column or rows. All right, so that it's cleaner when you do processing. Okay, so you do the filtering over here. So this is to preview what are the contents of the data that you are importing. Okay. So usually what we can do is like to import the data, you can actually do, let's say it's here, right, calls data. You can actually drag and drop, and it will do pre-configuration for you already. Like over here, it already pointed to the exact location, or you can make some changes based on what you want to know. Okay, you can do that. So this is the older version. Like newer version, they have support for Excel as well. All right. So if you want to view, let me bring this down so that you can see it clearly. You want to view what the contents inside. Okay. So earlier was in the configuration window. So the preview option there. So you don't have to open that. You can actually right click and select the file table. Okay. So that you can see what are there inside. Okay. So whether voicemail message, like how many they are using, like what are the minutes in a day that they spend, like evening minutes, the night time, international minutes, okay, customer service calls, day calls. So all these information about their usage are in this Excel file. All right, then so I'll just use the earlier one. Okay, so we can ignore this. And next is contract data. So what is the contract data is about? Okay, let's view what's inside. So contract data is like their phone number and their account length, and whether they actually churned or not. Okay, so we have the outcome outcome already. We call it labels. Okay, so we already know their usage statistics, and we already know whether they churn or not. So based on that, we train that model so that if this and this, whether they churn or not. So it will structure that model in that way. When you add new data with particular values, so it can actually fit into the model. So without having the churn column there, it can actually predict whether they will churn or not. So that's what's happening here. Okay, so now these are two different files, right? And they are pointing to the same subscriber sometimes. So we need to join those two data into one file. All right. So when you execute, you can actually see the joint table. So before that, let me open up the configuration window for that. So what they're doing is like they only join when the area code and phone number matches. So let's say the same phone number appears in two of the files. It will join those two data into one, so that you'll know all the details about the particular subscriber. If it does not match, let's say one of the phone number is only available on the first file, and in the second file you don't have the subscribers info. If it doesn't match, it won't include there. So only those that are matching, it will include in the output of the joiner node. All right. And if you still want to have those data from the other file, let's say from here, you can actually select outer join, like left outer join for the first file, right outer join for the second file, or full outer join. Like, doesn't matter if it matches or not, you will just include everything, and if it matches, you will just put in one row, something like that. All right. So this is the joint table with all the data combined. Right. So some of the columns are from the first file, and some of the columns are from the second file. So all of them are joined. And after that, so we want to change the area code and churn values so that it doesn't interfere while training. All right. Okay, we change the number to string so that while training it doesn't interfere with the training. Okay, if it's in number form, sometimes it can cause trouble when you do the training. So after that, okay, if you see the transformed data, you can actually see the churn is a string S. Okay, it's a string, and this state, area code. Area code is an S as well. Okay, so it's a string. So after that, we'll give a color for the churn. So if you look at the output, so those who churn will have a blue color, and those who do not churn will have a red color. It's easier for visualizations later on. All right, so that's a color manager. So we can do so many things with that, even for like generating like a plot or something. You can use color manager as well to give different color for each of the columns. All right. And so before you feed into a training, usually what we do is we split the data. So over here we have like 3,333 rows, right? So we split it into two. So the 80% of the data, we use it for training, and the 20% of the data, we use it for testing. So what's a training and testing data set? So training is what we use for training the model. And after we do the training, we use back the test data set without the label. In this case, is churn, right? Whether they churn or not. So we don't give that outcome, and we test and see whether it's matching with the actual model, like whether it's trained properly or not. Okay, so that's to make sure it doesn't what do you call it, overfit to this particular data set. All right, so sometimes when you do the training, if you don't do testing and all, it can work perfectly for that particular data set, and when you introduce newer data set, it won't work as accurately as before, because it actually like fit to the particular training data set and doesn't generalize well for other new data that are coming in. So this is a good practice to do. So what we do, then we feed the data, partition data, the 80% of the data, into decision tree learner. Okay, this is where the model is being generated. All right, so now you train the model already, so it's already there. So okay, so I can show you how the model looks like. Okay, this is to give you an idea of what the decision tree looks like. This is how it is. Okay, later I'll come back to like what are they, I'll explain a bit on machine learning a bit in a while. Okay, so based on each of the columns, it splits. So on next stage, if it matches, like let's say below day charge, so below this value, it will split, and then above this value, it goes there, and it will expand further and further until you'll reach the end. Okay, so this is how it works. Like it will do like a structure so that all these criteria are met, and then whether it will tell you whether they churn or not. Okay, and now you have the trained model. So what you can do next is you can use that to predict. Okay, so over here they feedback the test set and check and see whether the model has trained properly or not. Okay, another thing you can do is you have the trained model, you can use a Bmml Writer. It stands for predictive markup language. All right, model markup language, predictive model markup language. So it stores that model in that file format, so that later on when you share with your peers or you use it in another file, you can access that trained model. Okay, so you do that. Let's save it as test.bmml. Okay, so it's already there, so it overrides on top of it. All right, so now you have feed the test data set into decision tree predictor. You can see the outcome. Okay, so this is the prediction. Okay, sometimes it predicted correctly, sometimes it didn't predict correctly. That happens. So it won't be accurate, it won't be correct all the time, but it will give you an idea of what happens most of the time, like the higher probability for each of the subscriber, whether they will churn or not, right? So there's another way to check how the model is performed. So that's to use a scorer. It will show you like, so this is the predicted value and this is the churn, right? So when it say they don't churn and it predicted correctly, it will add 1 here, and when they say they will churn and it actually in the prediction, let's say it said they will churn, and the actual outcome also from the test data set, it also says they churn, so it will go here. And let's say it predicted that they will churn, and in the test data set they didn't churn. Okay, it will go here. These are false positives. So this is a true negative, meaning the predictor and the label are both saying negative, and the predictor and the label, if they are both saying positive, they are true positives. All right, and this is the other one, the opposite of that. Okay. We can also do ROC curve to check how well the prediction have performed. So this is the area under the curve. So the higher the number, the better. So usually it's between 0 and 1. So this is actually performed really well. So the true positive rate is actually high. All right, means the model is performed better. And also, let me show you like other features of the KNIME, like what you can do and all. So now you have saved that model in your local directory, right? What you can do is you can access it back, and this time you have new data from somewhere, and you want to check whether they will churn or not. So you point to that location, like, so this is the new data from here, okay? And then you access that model, okay? So test Bmml was our model. If you want to run the whole workflow at once, you can actually run the end node, and it will automatically run all those nodes that are required. Okay, so over here it publishes to a report. Okay, let's look at that. So usually when you want to do reporting, you have to structure it before you publish. So I won't touch in detail on that. I'll just show you like how do you structure now. So you structure it in this format, like where to put each of the values inside the report, and then you run. Okay, then you have the report automatically generated. So this is a simple report. I can show you some of the advanced reports that are out there. So this is another workflow, okay, for local restaurant performance when they go for inspection, like their scores when they did inspection. So let's look at its report here. So they structured it like to be in this format. So let me show you what it looks like when you feed all the data inside. All right. You only set the layout of the report, and it will generate the report automatically for you. It's actually handy when you have like the same type of report being same type of data being generated at the end of the cycle, like every week or every month. So you want the same report over and over again. So you feed in different data, and it will generate the same the report with the same layout with different data. So you don't have to do the report manually every time when you do the reporting. Okay. So that's one of the feature of KNIME. And visualization. Let me pull one of the visualization that I can show you. So you can do a lot of visualizations in KNIME. So some of the common ones are like scatter plot, stacked area chart, line plot. So I can show you how it looks like in KNIME. Okay. You can also make it interactive, like yeah, you can filter it in the plot itself to show like only the data from particular range, you know. So that's one of the things you can do. You can also like add multiple charts in a single plot like this. Okay, so let's say when you select a particular age, so it will show like what are the activities. Okay, so what are each of the age groups being represented in this web activity over here. Okay, quite useful when you want to do visualizations and make decisions based on that. Okay, that's about Nime Analytics platform, and I can show you like, okay, and another thing is like it supports Python scripting as well. Like let's say you know how to do model training or configurations on Python, you can actually use those Python scripts inside and feed the model from here and train it on the particular node. Like under the scripting, you can see like Java, and you can get like Python nodes. I didn't download it yet. It should be there. All right. So that's about KNIME. Let me get back to the slide again. Okay. So before I end this webinar, let me give some introduction to machine learning so that you know what was going on earlier. So we looked at how the KNIME platform works, like how you can interact with it to create your workflow and everything, make it useful to do some data analytics and more. And machine learning is, as I said earlier, it's not required for data analytics, but it's better if you include it in data analytics. So what is machine learning? Machine learning is a subset of artificial intelligence and is a superset of deep learning. So deep learning is one of the branch of machine learning, and machine learning is one of the branch of artificial intelligence. Okay, and it's a study of computer algorithms that improve automatically through experience. Okay, so let me give you an example. Like this is used for spam email filtering. So previously, what they did was they do the to filter out the spam emails. They write the rules manually one by one. Like if the email contains this particular word, you have to mark it as spam, and you have to write the rules every time. And let's say the spammer improves the email and includes like avoids that particular keyword that you flagged, and you have to update it every time they make the changes. So this is a bit tedious, right? Like you have to do a lot of work manually. So that was the traditional approach without machine learning. And after we use machine learning, like the different approach to spam filtering, we actually made the process a bit like simpler. Like what we do is like we study the problem. Like we flag a particular email and it will look for keywords that's common in each of the spam emails. And when we do the training, it will build like a model so that every time you get a new email, you will go through that model and it will predict whether it's a spam or not. And it improves every time you flag a new email as spam. So you don't have to manually set the new rules and everything. So in this way, it's actually way simpler than how you do it manually. So that's one of the improvements that you can do with machine learning. Okay, and these are the different types of machine learning out there, and the most commonly used one is supervised learning. So it's usually task driven, and unsupervised is data driven, and there's reinforcement, which is very rarely used, like only in specific cases they will use reinforcement learning. So usually in robotics and all, so they use reinforcement learning. And supervised is when you know the labels, like what are the outcomes going to be, like when you feed in the data set, right? So you already know the outcome for each of the features meaning the data sets. Okay, so you feed in with the label and you train it with the label so that it knows what is the outcome. And in unsupervised, you don't know the label, you don't know the outcome for each of the data set. So what it can do, like for example, you don't know the outcome, so what it can do is like it will group each of the data set based on their similarities into clusters. Okay, it will do some clustering and it will group it based on their similarities, so that let's say it satisfies a particular set of characteristics, it will put in that group that it split it. Okay, that's about supervised and unsupervised. And these are the applications of machine learning. I won't get into details of it. So what I can show you is like, so under the supervised learning, right? So there are classification problems, like regression problems. Classification is when you want to do like the data, the output should be in discrete format. Like you classify whether it's a spam or not spam. Regression is like continuous output, like house price, like the temperature. Okay, so it will be continuous in a number sequence, not a sequence, like regression is like it doesn't say whether it belongs to particular class or not. You can't really classify. All right, and under unsupervised, the most common one is clustering. So that's all we're going to focus on this slide. And these are the examples of machine learning models. So under the supervised learning and under classification, the common one that we will use is support vector machines, also known as SVM. Nearest neighbors, also known as K nearest neighbors, or KNN. And yeah, under regression, for machine learning, the most common one is linear regression, ensemble, or also known as random forest, and decision tree. So also commonly used. And under unsupervised, so the k-means clustering is one of the most widely used out there. All right. So that's about the examples of machine learning models. So before we end our session, let's have our quiz time. And before that, if you have any questions, you can actually ask right now.
Thank you very much, Leon. I think we have few questions on the floor here. So we have a question from Muhammad Munzir. He is asking, may I know where to get KNIME Analytic installer?
Okay, so I can share the link for the KNIME download page. It's actually, you can download it for free, and I think you need to sign up before you download. Nime. So this is the page for Nime, website for Nime. So when you click download, and you fill up the information, and you can actually download from over here. Okay, it's available for Windows, Mac, and Linux as well. Let me post it. And you have access to like example flows, and also like example exercise that you can use to learn by yourself as well in the Nime site. And Nime, there's a thing called Nime Hub. Nime Hub is where people share their codes among them. Like let's say you make like a flow right over here. Let me, okay, look at here. You can actually group it into a component. Let's say you name it ML model or something, for example. Okay, so it will group it into a component, and you can actually share it in Nime Hub, right over there. So people have already like created so many components that you can make use of. Instead of doing it from scratch, you can actually look for the readily made components out there and make use of them from Nime Hub. And so another question came from, may I know whether Nime need license to use it? To use it, it's free and open source. You don't need to purchase a license. And trials, yeah, it is free. The only thing that you need to pay is when you want to use their server platform, where you can collaborate with others. So that's that one you need to purchase the license. Other than that, it's free to use. Okay, and Eric, yeah, it is similar to Node-RED, yeah, because the interface it's using, it's we interact with it to code it in visual programming, like you drag and drop, do the wiring, and it's different in the sense that you can run each of the nodes separately. In Node-RED, you have to deploy the whole flow, right? Like a whole connection has to be deployed at once. In Nime, you can deploy one node by one node. That's the difference. Okay.
All right, thank you very much to both Munzir and Kim Seong for your questions, and I hope Leon answered your questions, the one that you're looking for. Okay, so now can everybody please participate in the quiz that Leon has provided here? Just follow the instructions there.
I've not started the quiz yet.
Okay.
Yeah.
Do you have anything else to add, Leon? Sorry.
That's all.
Okay.
Okay, starting now. Right.
So is this the top 5?
Top 5, yeah.
All right. Okay. So I think I've got the screenshot here. Is there anything else that you like to add today, Leon?
That is all from me. Like before I finish my slides, so I can give you the answers. So this one is L5. So data analytics is data that we analyze. It's not the data, but it's the technique that we use to analyze data. And so most time-consuming task is data pre-processing and cleaning. So that takes like 80% of our time usually when we do data analytics. Not the training part, but the cleaning and pre-processing. And number 4 is, okay, so supervised learning, we need to have the label to train. Okay, so that's for this quiz. Okay, so that is all. All right, thank you.